Hello, this is Mr. Frank, and welcome to day 2 of I Can Graph Transformations on a Coordinate Plane. So after we do this learning target, we're going to review and then do our summative. So just a quick vocabulary review from yesterday. We talked about reflections, that's a mirror image, as you can see here. We briefly mentioned rotation, which is where you turn an image, and translations, where you move an image. And I have a couple of other ways, another way to look at this. So here's a reflection in a mirror. So blue and red are reflecting. Translation, you can see that this moves or it's pushed over. And rotation, the blue is turned to create the red. We're going to be focusing on translation today and rotation today. So let's get into it. So translation, the definition. I'll read this. It's a transformation that moves each point of a figure the same distance in the same direction, also known as a slide. I like the quick definition better. It moves an image, right? And you can see here, if we start at A, B, C, D, this quadrilateral, we're going to move this image here. It's moved in, each point here is moved in the same direction and the same distance. And we can write a rule for this direction and this distance. And here's a rule. This figure slides 7 units to the left and 3 units down. Let's see. Let's start with point A and go 1, 2, 3, 4, 5, 6, 7 units to the left and 3 units down. 1, 2, 3. And I get to point A prime. So that makes sense. Let's try point D. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. There's D prime. So the rule here is this figure slides 7 units to the left and 3 units down. Whenever you have a translation, there will be a rule that will tell you how to move the image. So here's how you would write it. There's a notation, it's called coordinate notation, where you say, we start with x, y. Remember in class today we talked about coordinate notation, but x, y would become x minus 7 because we're moving 7 to the left, so it's negative. And then y, it becomes y minus 3 because we're moving down 3. So if you're moving up and to the right, it's positive. If you're moving down or to the left, it would be negative. Replay that if you're not sure. That's a pretty important concept. So let's describe this translation from blue to the red figure. So let's count. We have 1, 2, we'll go from A to A prime. 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3 down. So 6 to the right and 3 units down. We said to the right would be positive, so x for the original object becomes x plus 6 for the image, for the new object, and y, when we move down 3, becomes y minus 3. So now you try. Describe the translation from the blue figure to the red figure. So pause here and come on back once you've done it. All right, welcome back. Let's see how you did. Let's start with, I'll just start with R. To get to R prime, I have to go over 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4 down. So it's 5 units to the left and 4 units down. Should that be negative or positive? Let's see, to the left is negative and also down is negative. So my translation rule, like how I would describe this translation would be xy would translate to x minus 5 and y minus 4. So I hope you got that. If not, again, rewind, go over it again. But now let's, oh, this is cool. I picked up some artwork. Check this out. This is all translations. You see this design here? I guess that's a Pegasus, flying horse. All of these are flying horses. You could take any one of them and translate it. Either the brown ones, or I guess the black ones are translated here, and then the white ones are translated. Pretty cool, right? So that's some artwork showing translation. All right, let's get into rotation. So the definition of rotation is a transformation that rotates a figure through a given angle, called the angle of rotation, and in a given direction also. It's also known as a turn. I like the quick definition. Turns an image. Easy to remember. So let's look at this one, this rotation. I've got 4 different triangles here, A, B, C, and D. So let's start with A. If I rotate from A to B, I'm rotating 90 degrees clockwise. So if you remember, 90 degrees would be a right angle. And you can think that I am moving this triangle 90 degrees around in the circle. Notice that we're not just moving it, we're rotating it as it moves. So it's rotating and moving at the same time. Think more like spinning, like a frisbee spinning. So this corner here becomes this corner here. And then it continues to rotate around. So when we're rotating from A to B, that's 90 degrees clockwise. What do you think rotating from B to A is if I go this way? Well, if you thought 90 degrees counterclockwise, you would be right. So counterclockwise means rotating in this direction. And I know we all use digital watches now, but if you think about a watch face, a traditional watch face, clockwise, the hands of the clock go this way. That's why it's known as clockwise. So that's how we got the term. And counterclockwise would be this way. All right, so let's talk about rotation. So we rotate the quadrilateral FGH 90 degrees clockwise. Oh, my degree sign got moved, so that should say 90 degrees. So let's see how that looks. So the original coordinates I've captured here. So you can see F is 2, 2, G is 2, 4, etc. The image coordinates are captured here. Can you see a pattern here? So the original numbers are here. And the image numbers are here. Now, X looks the same to, or I'm sorry, what am I saying? X, let's see, I go from, here's 2, here's 4, and negative 2. So look at that. So the Y here becomes the X. The Y becomes the X. And what does the X become? The X becomes a negative Y. Look at that. So 5, 2 becomes 2, negative 5. So what do we think the rule is? If we write the rule in coordinate notation, xy becomes y negative x. Now take a look again up here so you can see that. So xy, so 5, 2 becomes y. So we move the y to the x, and then the y rather, is a negative x. So let's take a look at that on the diagram. So why don't we take j? So j is 5, 2, and j prime is 2, negative 5. So make sure you write this down in your notes. This is an important rule here for when we're rotating 90 degrees clockwise. And now let's look at a rotation for 180 degrees. Notice when I say 180 degrees, I don't need to say clockwise or counterclockwise because we end up at the same place. 180 degrees ends up in the same place. So here's my original coordinates, and here are my image coordinates, the blue coordinates. Can you see a pattern here? So it goes negative 6 is my x value, and 0 it becomes 6 and 0. Here negative 5, 2 becomes 5, negative 2. So it looks like xy becomes negative x, negative y when we're rotating it 180 degrees. So let's take a look on the diagram. So B is 5, negative 2. I'm sorry, B is negative 5, 2, and B prime is 5, negative 2. So you can see when you rotate 180 degrees around, you're taking the negative values of x and y to get your coordinates. So you try. Which shape is a 180 degree rotation of shape A? And what are the coordinates of the 180 degree rotation of A? So first figure out which shape it is, then determine the rule or the key for the code. So why don't you pause and come back once you've done that. All right, welcome back. So you should have figured out that C is a 180 degree rotation of A. And the rule, as we said on the last slide, was xy becomes negative x, negative y. And these are the coordinates that you should have come up with. So you can pause and make sure you got that right. All right, and hopefully you did. And here's some artwork. I thought this was cool. Some artwork showing rotation. So you can see here's a point of rotation where everything revolves around this point. And there's some other points of rotation as well that you can look at. You kind of have to stare at this to see the rotation, but you can pause it and do that. And now on your own, which shape is a 90-degree rotation of shape A? So the last time we did 180-degree. Now I'm asking for 90-degree rotation of shape A. Oh, I didn't put it in there. 90-degree clockwise rotation of shape A. So do clockwise. And what are the coordinates? First figure out which shape it is, and then determine the rule for the code. All right, so pause here, and once you've done it, bring it back to class tomorrow, and we'll go over it. As always, please capture what you learned or were reminded of, and questions that you have are. Hope you enjoyed the video.